Hi, biochemistry students. Welcome to another ideas session. And today, what we'd like to do is kind of focus on predicting products. And I'm just going to show you some things from one of the worksheets called Predicting Products and Reaction Types. Anyway, so I'll show you on the board, but I just kind of want to give you some tips. I've got up here on the screen here an example of some of the problems on that worksheet. And the first one says potassium iodide plus chlorine in sentence form. And so, that's pretty challenging because it's like pretty vague. So where do we go from there? And then let me slide down here on another one here. I think it's number 5. Um, Let's see. So I'll do these two problems, but number 5 is magnesium reacts with phosphoric acid. So, like, how do you know what the acids are? We haven't really gone over that yet. So, anyway, we want you to try these. These are challenges, but anyway, let's take a look. Now, also, I want to show you that when I do problem solving, and I would recommend that you do this too. Let me show you a couple things up here on the screen. Always have your uh, periodic table available handy and your reference chart. So before you even start to begin these problems, make sure you have those available for you. Now I'm going to switch over here to up here on the board and we'll work these out. Now in the first one here, potassium is just simply, or potassium iodide would be, how do we know what the formula is? Well, potassium is a +1 charge and iodine is a -1, so it's just Ki. We know that because of where potassium is on the periodic table and we're iodine. And so potassium's +1, iodine's a -1, so that's just Ki. Now, chlorine, this is a tricky part. So, we're assuming you might know if I just say chlorine that that's the chlorine gas. You may not know that. So it is. So one of the things about that is any of these gases that we see, let me go to the periodic table again. Um, so if you'll notice and you'll look at your periodic table, the halogens here, fluorine, chlorine, bromine, iodine, and also oxygen and nitrogen, they all form diatomic molecules such as Cl2. Okay, so that's just something you learn as you go along. But anyway, let's see what our products could be here. Obviously, potassium is going to join with chlorine and it's going to produce potassium chloride. And then what's going to be left over is iodine. So iodine again is one of those diatomic molecules, so it's going to exist as I2, a diatomic molecule of iodine gas. Okay, so let's see if we can balance this. Well, there's 2 chlorines here. Only one here, so we can put a 2 here. And we know there's 2 iodines down here, so we can put a 2 here. And as we double check that, that is correct. Now, here's this problem number 5 is magnesium reacts with phosphoric acid. How would you know what that is? So let me give you a little tip on that. Magnesium is a metal, and it's just going to be represented as Mg. Okay, whereas phosphoric acid that's kind of a different thing. All of the acids begin with H. So let me show you how you draw that one. So I'm going to switch you back over here to our reference table here. Let's go ahead and switch over to that, which is here. Now, phosphate on the reference table phosphate is right here. It's a -3. So when you look on your reference chart, you'll see it as a -3. So that means that it's going to have a hydrogen attached to it. So hydrogen is a +1. And so we're going to write phosphoric acid as H3 because hydrogen would be a +1 and phosphate is -3. So they go together that way. So it would be H3PO4. And that is phosphoric acid. Now, you could always look that up on the internet as well, but that's kind of what we're looking at here. And by the way, this right here is a single replacement reaction. This first one we did here, that's a single replacement. And that's what this one's going to be as well. Both of these are examples of single replacement. So let's see